This is a video from section 3.4. The directions say to find the equation of the tangent line to the curve at the given point. Let's go ahead and start with problem 57. On problem 57, we have the curve y equals 2 to the x, and the point is 0, 1, and we want the equation of the tangent line. But to get the equation of the tangent line, we need to first find the slope of the tangent line at the point 0, 1. In order to do that, we need to find the derivative first. And so y prime is equal to 2 to the x times the natural log of 2. Now, at x equals 0, y prime is 2 to the 0 times natural log of 2. But 2 to the 0 is 1, and 1 times the natural log of 2 is the natural log of 2. And so we're given slope natural log of 2 and point 0, 1. And so let's find the tangent line. Because to get the tangent line, you need a slope and a point. Well, we know that y equals mx plus b. M represents the slope, but we know the slope is natural log of 2. So y equals natural log of 2x plus b. But this line has to pass through the point 0, 1. And what that means is when x equals 0, y has to be 1, right? And that implies b equals 1 immediately. Therefore, y equals natural log of 2 times x plus 1. And this represents the equation of the tangent line through the point 0, 1. And that's problem 57. Let's take a look at 59. Same directions. And in 59, we have y equals sine of the sine of x. And the ordered pair here is pi 0. Now, the outside function is sine, right? The derivative of sine is cosine. But remember, we're evaluating cosine at the inside function. The inside function is sine of x. So we're going to get cosine of the sine of x. And we're going to take this result and multiply by the derivative of the inside function. The inside function, again, is sine of x. The derivative of sine of x with respect to x is cosine of x. So I always like to think of this like peeling an onion. We work from the outside in when we take the derivative of a function like 59. Okay. Now, at x equal pi, y prime is cosine of sine of pi times cosine of pi. Now, sine of pi is 0. So we get cosine of 0 times cosine of pi. Cosine of 0 is 1. Cosine of pi is negative 1. So this is 1 times negative 1, which is negative 1. So we're given slope -1 and point pi 0. We can now get the equation of the tangent line. I'll use the same method as problem 57. Y equals mx plus b. We know m is -1, so y equals -1x plus b. But this time, when x is pi, y equals 0. So I'm going to plug those pieces in. So 0 equals -1 pi plus b. And what that tells me is b equals pi. And so therefore, y equals -1x plus pi, or we can write it this way, which is the way I would say most instructors would take it, is we would write y equals -x plus pi. And that right there is problem number 59. If we take a look at this one, let's take a look at 67. Suppose capital F of x is equal to f of g of x. Where f of -2 equals 8, f prime of -2 equals 4, f prime of 5 equals 3, g of 5 equals -2, and g prime of 5 equals 6. We want to find f prime of 5, and I do mean specifically capital F prime of 5. Now, we're going to start with this function up here. So we're going to start here. Capital F of x is f of g of x, okay? And we need to take the derivative. So capital F prime of x, I'm going to take the derivative of the outside function, so we'll say f prime, evaluated at the inside function is g of x, and we're going to take that result and multiply by the derivative of the inside function. Chain rule. Now, replace x with 5. So f prime of 5, capital F prime of 5, is f prime of g of 5 times g prime of 5. Now, if I take a look at g of 5 right here, I need to come up here and notice that g of 5 is equal to -2. So I'm going to replace g of 5 with -2. So capital F prime of 5 is equal to f prime of, and again, g of 5 is -2 times g prime of 5, which is 6. That's right here. So I'm going to multiply by 6. Now, f prime of negative 2, if I come here, I notice that that's 4. So this is equal to 4 times 6. And so it looks like f prime of 5 is equal to 24. So in a problem like this, I took the derivative and I just picked out the information that I needed. And it doesn't look like I needed all of the information, as you will see. And that's problem 67. If we take a look at problem number 68, if h of x is the square root of 4 plus 3f of x, which, if you don't mind, I'm going to write this as 4 plus 3f of x raised to the 1/2 power, where f of 1 is equal to 7, and f prime of 1 is equal to 4. The question says find h prime of 1. And so h prime of x is 1/2 of, applying the chain rule, right? So I get 1/2 of 4 plus 3f of x to the negative 1/2 power, right? And I'm going to multiply by the derivative of the inside function. The inside function is 4 plus 3f of x. The derivative of 4 is 0. And so we're just left with 3f prime of x. And so I'm going to replace x with 1. And so now 1/2 of 3 is 3/2. So if you don't mind, I'm going to write this as 3/2. And I'm going to put 4 plus 3f of 1 in brackets raised to the negative 1/2 power times f prime of 1. Now, f of 1 is 7. That's up here. So this is equal to 3/2 times the quantity 4 plus 3 times 7 to the negative 1/2 times f prime of 1 is 4. So I'm going to put a 4 there. But 3/2 times 4 is 6. So this is 6 times 25 to the negative 1/2, which is 6 over 25 to the 1/2. But one thing to note, 25 to the 1/2 is the square root of 25, which is 5. And so this is equal to 6/5. And so therefore, h prime of 1 is equal to 6/5. And that's problem number 68. And that'll conclude this video for section 3.4. We worked on problems 57, 59, 67, and 68. Thank you.